Assalamu alaikum. This video for subtopic 5.3. So as you can see here, we have two poles moving toward each other, both in the positive, or both have the positive displacement. How will they interfere? Actually, here we will use the superposition principle, where we add the amplitudes because they have the same direction. So here we will have constructive interference, and we will add the amplitudes. So 3 plus 3. So this is 3, this is 3. The result of this interference will be 6 centimeters. So the answer is D. So we just add them, okay? Now, let's go to question number 2. We have here this interference, or these two poles. Also, they have the same direction, and they are moving toward each other. Each one has amplitude 0.3. So when they interfere, it will be constructive, and we will add them. Now, if they were in opposite direction, let's imagine. If one of them was like this, the other one was like this, and they both have same amplitude, let's say 3 and 3. What is the result interference? Actually, the result interference will be 0. Okay, so in this case we will subtract if it's not 3, 3. Let's say one of them is 3, the other one is, the amplitude of the other one is, let's say 2. The result will be 1 upward. So we just subtract them and we will find the answer, okay? So here I'm just saying if. We don't have this now, but the idea is covered. Now, what is the total number of nodes and antinodes in the standing wave here? Always 1, 2, 3, 4, 5. Those are the nodes. The antinodes always 1 less. 1, 2, 3, and 4. So the answer is C. It's just counting. So nodes and antinodes. Nodes where we have destructive interference. Antinodes where we have constructive interference. Let's look at the next. A string with mass 1 kg and length 2 meters is under tension of 40 Newton. What is the wave speed of the string? Actually, wave speed equal radical T over M over L. Let's look at the formula sheet and find it. Okay. This is the velocity. Clear? It's here. V equal T over M over L. Okay. Now, Bismillah. So, okay. Now, the velocity equal radical 40. Of course, T here is not the tension, it's the force. Sorry, not the period, it's the force. So we need to be careful. I don't want you to be confused. So let's call it ft instead of t, because يعني some students would say it's period. لا, it's not the period, it's the tension. Okay, so 40 over 0.1 divide by 0.2. So the answer is 28 meter per second. And let me correct here. It's 2. Okay. Next question. What will happen here? The wave is moving from, let's say, one depth of water to another depth of water. What will happen? The wave will change the direction. It will have refraction. So the wave will change direction okay, بين قوسين, let's say between two brackets, refraction bس, that's it. Which region, A or B, less deep? Region B will be less deep, and I will explain why. Region B. Why? Because less depth in water means less speed. Less depth means less speed. So as you can see here, at this part, the speed of the wave is less. Look at the red part. Red part is slower than the other part, right? So that means it has less depth. Okay, what are the quantities that change for the wave that enters from region A to region B? Actually, when any wave change the medium, the speed will change, and the wavelength. Now, next question, what happened for each one of those? The speed, as we said, since it's going to less depth, it will decrease. The wavelength will decrease. Of course, if the speed decrease, the wavelength decrease. To keep this formula, we know that velocity equal frequency times lambda. So frequency is constant. The frequency here. Next question is the frequency, no change. The frequency will not change when it moves from one medium to another. So if the velocity decrease, the frequency will and the frequency is constant. In this case, lambda should decrease. Clear? Where this one is constant. طيب. The direction will change, actually. Will change. بين قوسين, between two brackets, refraction. Now, that's it for 5.3. Thank you.